So our first topic in the two-port network is Z parameter. So it is called by different names, that is impedance parameter, okay, and it is also called as open circuit parameter. So impedance is represented by Z. So this is called as Z parameter. So in any of the questions, if any of these three terminologies are used, then we can tell it as it's a question of Z parameter. Okay. So now in this case, whenever Z is involved, what we can analyze? We have got three parameters, V, Z and I. Okay. So these are the three parameters involved in the Z1. Okay. Formula is nothing but Z is equal to V upon I. Okay. So this is how we will represent impedance, right? We need the voltage and we need the current. Okay. So now we will write this as in the matrix form. It's nothing but V can be written as Z into I. Okay. So this is V, this is Z and this is I. Okay. So I will come here. We can write if we take two parameters V1 and V2 because it's a two-port network. Okay. I can write as V1, V2. Okay. This will be equal to, now Z we will write it, fill this matrix later. Okay. And we have two output network, that is one is I1 input and I2 will be output. Okay. So now in this case Z1, since it is a 2 cross 2 matrix, this will be Z11, this will be Z12, this is Z21 and this is Z22. Okay. So these are the 4 parameters for the Z parameter. Coming to this, from matrix to equation, how can we write it as? We can take V1. Okay. So this V1 equal to, it's nothing but multiplication of this first row by this column. So I can write as Z11 I1 plus Z12 into I2. Okay. So this is equation 1. Next, similarly for V2, I can write it as, okay, Z21 into I1 plus Z22 into I2. So these are the two equations that we get from this matrix. Okay. So it is nothing but V1 equal to Z11 I1, just I have multiplied this and written in two equations. Okay. After this, now we will analyze, okay, there are two dependent and two independent. So which are the two dependent? V1 and V2, they are called as dependent. Okay. I1 and I2, they are independent quantities. Okay. So when you vary I1 and I2, then only V1 and V2 will vary. So that is why voltages is dependent on current. Now to get the Z11 parameter, okay, so we have 4 unknown quantities now. Z11, you can write this Z11 as, put I2 equal to 0. Okay. So when we are analyzing one quantity, we will make the other quantity as 0. Okay. So when I2 is equal to 0, you will get Z11 as V1 by I1. This is when I2 equal to 0. Okay. So when I2 parameter is 0, we will get Z11. Similarly, again in this equation also I2 is 0. So again we will get Z21. Okay. So Z21 is nothing but equal to V2 over I1 when I2 equal to 0. Okay. So this is the parameter. Now we will analyze when I1 equal to 0. So when I1 equal to 0, we will get Z12, which is V1 upon I2. This is when I1 equal to 0. Similarly for Z22, when I1 is equal to 0, we will get V2 over I2, I1 equal to 0. Okay. So these are the 4 parameters, and for these 4 parameters we have got words. Okay. When they are like, we have the naming for this also. So when we are calculating Z11, we call it as input driving parameter or impedance. Okay. So input driving Z parameter or impedance also you can call impedance parameter. Okay. Why we are calling it as input? That is because, see, here it is also V1, here also it is I1. So one represents one dash terminal represents what? It is the input terminal. So that is the why this name is input driving impedance parameter. Coming to the second one, we have got V2 and I1. So here it is like V2 is the output and I1 is the input. So output upon input is nothing but something like transfer, right? So transfer function is written from output to input. So that is why the name of this one we can give it as forward transfer impedance. Okay, the name for Z21 is forward transfer impedance because I1 is flowing over here, V2 is output. Okay, so Z12 we have V1 and I2. Now this is reverse. So that is why we call this as reverse transfer impedance. Okay, so this is forward transfer impedance and this is reverse transfer impedance. And Z2, I2 again they are output, so we will call it as output driving impedance. Output driving impedance parameter. Okay, so these are the four names. So basically how you can represent this is, okay, you have a network here like Z11, Z12, Z21, Z22. Okay, so this is in terms of giving the input I1, this is V1. So this is terminal 1, 1 dash and this is the output terminal, this is I2, okay, with terminal 2, 2 dash. Okay, so these are all the parameters will be inside this 2-port network with the dependent sources. Okay, so this is the representation and this is Z11. So naming is not so important for the gate point of view, but you should know what are these. Okay, sometimes it may be asked in objective in various other exams, okay, competitive exams like JEE, SSC and all. Okay, so these are the 4 parameters that we have to find out. Okay, so coming to synthesis circuit. Okay, though this is not in our syllabus, since we are discussing theory, okay, we will discuss this synthesis circuit also. So the synthesis circuit is nothing but we know input quantities, output quantities. Okay, in the first lecture we have seen what is the meaning of synthesis. Okay, input will be given, output will also be given. We have to design this circuit. So, okay, that we will call it as synthesis. Okay, similarly we will do here also. We have got these 2 equations. So we will design the circuit. So how we will design? This is Z parameter over here. Okay, we can take it as Z11 and we should have dependent sources. Okay, so for this one, this current is nothing but I1. So I1 into Z11 we already got. We have taken this dependent source. We want Z1 to I2. Okay, so I will design this dependent sources Z1 to I2 which will depend on this value. So it is nothing but voltage dependent current source. Okay, next coming to this one, for the second equation, so this is V1. Okay, for the second equation we can write it here as this dependent source. Okay, for this dependent source Z21 into I1. Okay, first I will redraw this one here, this will be V2. Okay, for Z22 I can directly write, this is because I2 current in this one, I can write this as Z22. For this one I can take this whole quantity. So again it is the voltage dependent, sorry, this is current dependent voltage source and Z21 into I1. Okay, so you have got input terminal, output terminal and in between you have got dependent sources with Z parameter. Okay, so this is the synthesis of the network. Okay, there are 2 more conditions for this one, condition for reciprocity and condition for condition for reciprocity and condition for symmetricity. So we have 2 conditions for this one, condition for reciprocity and the second one is condition for symmetricity. Okay, so these 2 parameters, what do they indicate? Basically it is nothing but excitation upon response. Okay, so in this equations we are going to write excitation upon response. So our excitation for this one will be V1, okay, and the output is nothing but response is nothing but I2. Similarly, here we can take this as excitation V2 and this as response I1. So this is the condition for reciprocity. So in the same thing as the theorem. Okay. Now coming to this symmetricity, what it says, Z11 equal to Z22. Okay. This is the condition for symmetricity. Now this V1 upon I2, okay, so where is V1 upon I2? This one, it is indicates Z12, V2 upon I1, V2 upon indicates Z21, okay. So for reciprocity this will satisfy, and for symmetricity diagonal element should be equal, okay. So this is the about the Z parameter. Now we will take some of the questions which are very easy. Okay, basically this is nothing but we are applying like KVL in the loop. Okay, so V1, V2. So this is the conventional method, and we'll also see the shortcut trick directly by taking the problems. So we'll move on to the problem. So coming to question number 198, we have to find Z parameters. Okay, so we have to find the Z parameter. There are 3 resistors. So now if you see the circuit, 4 ohm, 6 ohm and 5 ohm, they are connected like a T shape. Okay, so this is the T shape. Okay, that is why we call it as T network. Okay, there is an objective to call it as T network because we'll apply the shortcut for that. Now for this to solve, we'll first go by conventional approach. Okay, first we'll go with conventional. Okay, so once we get with conventional, then we will move on with the objective shortcut. Okay, how to solve in the GATE exam. Now this is I1 current entering, so this is plus minus, and here it is plus and minus. These two are entering, and the current in this one will be I1 plus I2. Okay, so we got all the currents in these 3 branches. We will apply KVL in this loop 1 and KVL in this loop 2. So to apply the KVL, we will move this way, V1. Okay, so in loop 1, V1 minus 4 I1 minus 5 I1 plus I2 equal to 0. So V1 minus 5 minus 9 I1 minus 5 I2 equal to 0. So V1 is 9 I1 plus 5 I2. This is equation number 1. Okay. Coming to second loop, we will again apply KVL over there. So it is plus V2 minus 6 I2, okay, minus 5 I1 minus 5 I2 equal to 0. So rearranging this, we will get, so this will be plus 5 I1 plus 11 I2. Okay, so we got this equation. We will compare this equation with our first derived equation, that is V1 equal to, we had Zi1 plus Z12 I2. Okay, this we will call equation 3, and for V2 we had Z21 I1 plus Z22 I2. So this is equation number 4. Now compare this equation 1 with equation 3. So when you compare equation 1 with equation 3, what you will get? Z11, okay, this is nothing but 9. Z11 is 9 ohms. Okay, similarly Z12 you get it as 5 ohms. Compare this equation 2 with equation 4. Z21 again you will get 5 ohms, and Z22 you will get it as 11 ohms. Okay, so when you arrange, this is nothing but 9, 5, 5 and 11. Here you will be having I1, I2. Here it is V1, V2. Okay, and this is the Z parameter. So this is the conventional approach, and for the objective shortcut approach, okay, we will rub this one. Okay, so we will see this one, how this is applicable, this shortcut trick is only applicable for T network. Okay, so now to calculate the Z11 parameter, that is this first parameter, what you have to do is just add these two. Okay, this network, one element plus this one arm, 4 plus 5 you will get 9 ohm. Okay, next to get the Z22 parameter, okay, diagonal elements, you add this one, 6 plus 5 you will get 11, so here is 11 ohm. And for to get Z12, okay, so just we will keep this arm value as it is 5, because we have seen in the symmetricity Z12 will be equal to, this is reciprocity, Z12 will be equal to Z21. So this is only valid for the T network. So we will see some more questions when they have given pi network, okay, there will be bridge network also. So we will see how that shortcut we will apply for that. Okay, I think this is clear for you. This is the conventional method you will go, and then that is the shortcut trick. So if you have to generalize this one, okay, so if this is ZA and this is ZB, this is ZC, okay. So you have got here I1, this is V1, this is I2 and this is V2. So to get the Z11 parameter, you will add both this, that is ZA plus ZB, and to get the Z22, you will add these two, that is ZC plus ZB, and Z12 equal to Z21, you will keep this as ZC. Okay, so we will move on to our next question. So we will go with the question number 199, which was asked in GATE 2014 electronics branch. So they have given this network and we have to find the options also given. We have to find Z matrix. Okay, so we had seen T network, now this is pi network. Okay, so basically T network we would call it as star network also, and for this pi network we had called delta network. So easily with this delta network it can be converted into pi network. Okay, so I can write this. Okay, so this is the star network. Okay, this is not T, but now you can write this as in this way. Okay, so these two arms are made flat and this is the one arm. Okay, so now when I find this one, if I call this as Z1, this as Z2 and this as Z3. So this will be Z1, Z2 and Z3. Okay, so this is plus minus, this is 1 1 dash 1, sorry, this is 2 2 dash, this will be V2 V1, this will be I1 and this will be I2. Okay, so now Z1 Z2 Z3. So how do you calculate Z1? So this is again basic concept, okay, converting from delta to star. So Z1 is here, see the connected arms for the Z1, 30 and 10. So multiply them, that is nothing but 30 into 10 and add all the other resistor, 60, 30, 90, 100. Okay, so this will be 3 ohms. Okay, so Z1 we got it as 3 ohms. Similarly for Z2, 30 into 60, okay, divided by 100. So 6 and 3, they are in, they will be in multiplication. So 6 into 3 is 18. So Z2 is 18 ohms. Coming to Z3, 10 and 60 are, the arms are connected to Z3, so it will be 6 ohms. Okay, 10 into 60 divided by 100, so Z3 is 6 ohms. Now you got the T network. Come to the options directly. So we know that in T network the Z12 and Z21 will be equal. So now here this is not equal, so we'll cancel it out. Okay, then rest other are equal. Okay, so we'll calculate Z11. How do you calculate? You'll just add 6 and 3. So it will be 9. So this option is also wrong. Coming to Z12, here it is 6 ohms. Okay, so when it is 6 ohms, this is 8, so this is also wrong, and this is the right answer for this question. Okay, so this is for the, okay, so this T network, it can be only applied for, sorry, this objective shortcut, it can be, okay, so this objective shortcut, it is only applicable for first to finding the Z parameter. Okay, this is the first condition, and the second thing, it should have T network. Okay, then only you can use the general formula that we have taken this like this, and to calculate this one and this one. It's only applicable for T network. Okay, so we will move on to the next questions in the next lecture. Okay, thank you.